Okay, let's try this again. On the last attempt, my computer froze right after this problem, so it's already written out for you, but I'll go through each one. We're doing Unit 4 in class worksheet on this video, and we're going to start with electrolytes. The first one is sucrose. Sucrose is all nonmetals, and it's not an acid. If you remember in class, the way we described electrolytes and non-electrolytes was that electrolytes are acids or ionic compounds, and non-electrolytes are going to be everything else. So this is nonmetals, and it's not an acid, therefore it is non-electrolytes. Sodium nitrate is an ionic compound, therefore it will dissociate, and it's an electrolyte. In fact, I'm going to go ahead and do question 2. This says from the list that are above that are electrolytes indicating what form they exist when they are added to water. So for sodium nitrate, when it's added to water, it is going to dissociate into sodium and nitrate, and of course water. Linolenic acid is an electrolyte because it's an acid, even though it doesn't begin with H. We could actually rewrite this one as HC18, H29, because we need to take one away, O2. When it's added to water, it will dissociate into H plus C18, H29, O2 minus. So this one will be an electrolyte. Hydrochloric acid, D, electrolyte because it's an acid. When it's added to water, it will dissociate into H plus and Cl minus plus water. KCl, this is ionic. Potassium is a metal, chloride's a nonmetal, so it's an electrolyte. And the way it would exist in water is K plus, Cl minus, plus water. Dextrose, all nonmetals, and it is not an acid, therefore it is a non-electrolyte. Sodium carbonate is ionic, metal plus nonmetal. So it's an electrolyte. When it's added to water, it's going to form two sodiums. There are two down here, whoops. Two here. So that will form two sodium ions plus one carbonate ion plus water. So this will dissociate and conduct electricity. All right. Moving on to homogeneous versus heterogeneous mixtures based on solubility. Question A says adding 600 micrograms of magnesium hydroxide in 120 milliliters of water. So this is what you're going to attempt to do. Here's the solubility limit of magnesium hydroxide. 0.64 milligrams in 100 milliliters of water. So we need to figure out, will this mixture exceed this solubility? Before we start anything, we need to convert 600 micrograms into milligrams. And we can leave this as milliliters of water. Now we can do this all in one single problem. 600 micrograms in 120 milliliters of water. And again, we need to convert the micrograms into grams and then into milligrams. Whoops. There's 1 e to the 6 micrograms in 1 gram. And there is 1,000 milligrams in 1 gram. And if we do this, all this math, 600 divided by 120 divided by 1 e to the 6 times 1,000, what we get is 0.005 milligrams per milliliter. Now we need to take this and figure out, this is 0.64 milligrams per 100 milliliters. We need to get it into milligrams per 1 milliliter. So we just simply divide it. And we get 0.006 milligrams per milliliter. Since this is less than the limit, then it will be a homogeneous mixture. All of it will dissolve. All right. If it was more than this limit, it would be heterogeneous, because not all of it would dissolve. Okay, let's try another one. Mixing 1.2 kilograms of potassium sulfate in 10 liters of water. Here's the limit, 111 grams per liter. So this one is already in grams per 1 liter, whereas this one was milligrams per 100 milliliters. So we won't need to do any division on this one. It's already in the proper units to compare it with what we are starting with. However, we need to convert kilograms into grams first. So there's 1.2 kilograms in 10 liters. So let's get that into grams per 1 liter. We just do one conversion here. When we divide by 10, that will give us the 1 liter on the bottom. And when we do that, we get 120 grams per liter. Now notice how this number is greater than this number. So what we're trying to do exceeds the solubility limit. Therefore, some of it will be left in the bottom and will not dissolve, leaving a heterogeneous mixture. All right. These are two problems that we did at the start of class yesterday. So let me walk you through them. We need to remember this, that in 5 milliliters of liquid, that's 1 teaspoon. Well, actually, we'll need it for this one. Excuse me. We will not need it for A. How many milligrams of ibuprofen are present in 12.5 milliliters of children's ibuprofen? I'm going to start with 12.5 milliliters. And we're going to say that in 1 teaspoon or in 5 milliliters, there's 100 milligrams. So I'm going to put 5 milliliters on the bottom, 100 milligrams on the top. 100 milligrams per 5 milliliters. That's the concentration. Cancel out milliliters, and I'm left with milligrams. Should get 250. The next one says, how many milligrams of guaifenesin are in 3 teaspoons of the syrup? Well, I don't see teaspoons anywhere on here, but I see a concentration, 200 milligrams per 10 milliliters. And I know that 1 teaspoon equals 5 milliliters. So I'm going to start with teaspoons and use my conversion factor. convert to milliliters, and then I'm going to place this concentration to get the milligrams on top. And when I do that, I should get 300 milligrams of guaifenesin. Okay, number 6. Percentage and parts calculations. There's a lot of these problems on this worksheet. Okay. So you can't really see it very well on the video, I think, but right here, this says 0.14% weight over volume fluoride ion. That's important for this question. I'm just going to write that in a little bit bigger up here, 0.14%, and this is weight over volume of the fluoride ion. This question is asking how many milligrams of fluoride are added to each tube of toothpaste. A typical tube is 110 milliliters. So I have the concentration of fluoride here, and I have the amount of toothpaste here. Okay? So here's how we can go about solving this. We know that 0.14% means 0.14 grams in 100 milliliters. Okay, we've learned that in class. So this is now can be used as a conversion factor. I start with 110 milliliters, and I just use this, convert to grams. Cancel out milliliters, but I'm not done. I need to convert grams into milligrams. Okay, and when I do that, I should get 154 milligrams of fluoride. All right. So if you ever wondered what that means on the back of toothpaste, now you know that this means there's 0.14 grams of fluoride dissolved into 100 milliliters. Next problem, there's 2 A's. Here's A number 2. How many grams of H2O2 are present in 5 milliliters of 30% H2O2? We actually did this one in class already. Nevertheless, let's go through it. Again, we need to interpret this number. 30% weight over volume means 30 grams in 100 milliliters of solution. I don't have 100 milliliters, I only have 5, so I'm interested in how many grams of H2O2 are in 5 milliliters of this solution. So I just set up a very simple calculation here, and I end up with 1.5 grams of H2O2. So in 5 milliliters of solution, that's 30% concentration, there is 1.5 grams of H2O2. All right, on to B. Describe how you would make 150 milliliters of a 3% starch weight over weight solution using water. Okay. Now I think on the key I have this crossed out because we're not going to talk about density here. So we're just going to say instead of milliliters, this is going to be grams. Describe how you would make 150 grams of a 3% weight over weight solution using water. Now it makes a little bit more sense. Okay. Remember that a 3% starch solution, weight over weight, is going to be 3 grams of starch over 100 grams of solution. I'm interested in making 150, so I need to figure out how many grams of starch I need. 150 grams of solution at a rate of 3 grams of starch per 100 grams of solution. It's going to give me 4.5 grams of starch. Okay, but that's not what the question's asking me. It says, how would you make this? Well, I would add 4.5 grams of starch plus not 150 grams of water. I would add 145.5 grams of water, because the total needs to be 150 for the whole solution. Remember, solution is solute plus solvent. So I'm going to add 4.5 grams of starch plus 145.5 grams of water to get the total to be 150 grams. Alright, I'm going to end this for part 1 and put a note of the video part 2.